Today in the episode.
Hello there. Today we will continue exploring the different options of trench and excavation wall shoring during the open cut method of utility networks construction. You can watch the first part of this lesson here. The link is in the description. And the next option for trench wall shoring with the open cut method we will explore is the diaphragm wall. There are several types of trench and excavation wall enclosures using the diaphragm wall. Trench type. Drilled piles. Piles made using jet grouting technology. A diaphragm wall made of drilled piles is used in soils with large clastic inclusions and in rock soils where excavation with a grab bucket is difficult. Boreholes for piles are drilled in a casing or with bentonite flushing using percussion or rotary drilling rigs. When constructing a diaphragm wall using the jet grouting pile method, a high-pressure jet of cement grout is used to break up and simultaneously mix the soil with the cement grout. The resulting soil cement forms a continuous wall, which, if necessary, is reinforced with steel pipes or reinforcement cages, pressed into the uncured soil cement mixture. The trench-type diaphragm wall method involves installing reinforcement cages into trenches excavated under the protection of a bentonite slurry, which are then filled with concrete. The bentonite slurry applies excess hydrostatic pressure to the trench walls and forms a dense waterproof gel coating on the walls, preventing their collapse during the work. The construction of the trench-type diaphragm wall begins with the installation of a shallow, 1.5 meters, reinforced concrete guide wall with strict vertical tolerances, which serves as a guide for subsequent work. Next, the diaphragm wall is constructed. It is built in separate sections, panels, in a staggered pattern, which are developed in one or several passes. Sections ranging from 5 to 8 meters in length are formed in 3 passes, 2 side passes, and 1 intermediate pass. Simultaneously with soil excavation, bentonite is supplied into the trench, replacing the excavated soil to prevent the trench walls from collapsing. The level of bentonite in the trench is maintained above the groundwater level. To separate the concreting panels, special stop-end separators are placed at the ends of each panel. These separators withstand the pressure of the poured concrete and prevent concrete from leaking from one section to another. The separators can be either removable or non-removable inventory elements made of metal or reinforced concrete. For trenches deeper than 20 meters, it is advisable to use non-removable separators that are part of the reinforcement cage structure. Concrete is delivered into the trench through a steel pipe that reaches the bottom of the trench. Usually, 2 pipes are used for a 6-meter wide panel. The pipes are filled with concrete and gradually lifted from the trench bottom so that the incoming concrete displaces the lighter bentonite slurry upward. The bentonite soil mixture is pumped back to the processing plant as it is displaced. the next video, we will conclude our review of the different options for trench wall shoring during the open cut method of construction utility networks and structures. Thank you for your attention. See you soon.